Hello dear students, today we are going to discuss the chapter number 5, lines and angles. It's a very simple chapter. Here we are going to discuss the different kinds of lines and angles. So let's directly get into the topics. First let's recall the basic terms we have learned in class 6 mathematics regarding lines and angles. First one is, what is a line? In geometry, a line can be defined as a straight one-dimensional figure and that has no thickness and extend endlessly in both directions. That means a line doesn't have endpoints. See, here AB is a line. Okay, it is extended in both directions. It is denoted by generally it is denoted by AB, a bar which extend in both directions. Now what is a line segment? A line segment is a part of a line that is bounded between two distinct endpoints. That is just a part of the line and it has two endpoints. That is called a line segment. Here see AB. A is the initial point and B is the final point. That means it has two endpoints. Generally it is denoted by AB, then just a line over the AB. That is called bar. And next the term is that ray. What is a ray? A ray can be defined as a part of line that has a fixed starting point but no end point, that has a specific direction. See here AB is a ray. This is the starting point of this ray A, while it has no end point. It is generally denoted by AB, then a ray over AB. This is the way how it is represented generally. So these are the basic terms we have learned in class 6 related to line. Then what is an angle? An angle, it is a figure formed when two lines or line segment meet. We will get the figure that is called angle. See here, AB is the one line and another line CD. If they meet at the point Q, we can call this meeting point as Q. Then the figure formed, that is AQC. This figure is an angle. This is the another angle. This is another, and this is the fourth angle. So this figure is called angle. This is not only in case of lines or line segment, in case of rays also. For example, one ray we have AB and another ray with the C. So these two rays AB and AC meets at the point A, then also the figure is formed, that is angle. Okay, so these are the basic terms we have to remember. Now let's discuss different kinds of angle. Here we are going to discuss the relation between different kinds of the angle. First one is complementary angles. When the sum of two angles is 90 degree, the angles are called complementary angles. That is the relation between two complementary angles. Then one angle will be the complement of another if the sum of two angles will be equal to 90 degree. For example, we consider two angles like this one is 25 degree and this is 65 degree. Two angles we have. Then we can say that 25 degree plus 65 degree, that is equal to 90. Therefore, these two angles are complement to each other, or we can say that these two angles are complementary angles because sum is 90 degree. When the sum of two angles is 180 degree, then the angles are called supplementary angles. Same as in case of complementary, here it is sum is 90, here it is 180. For example, we can say that consider two angles with its measure is 75 degree and the measure of the second angle we are considering it as 105 degree. Then sum is equal to 75 plus 105 degree, which is equal to 180 degree. And next relation is that adjacent angles. Adjacent angles are the angles with a common arm and a common vertex. If two angles have common arm, that is side of the angle, and a common vertex, then we will call such types of angles as adjacent angles. See here, this is the one angle and this is the another angle. Am I right? Two angles we have. And here, this is the common vertex of the whole angle. For example, we can call that is O. O is the vertex of this first angle. This is first, this is second. O is the vertex of first angle as well as O is the vertex of second angle. And this is the common arm. So these two angles are called adjacent angles. Fourth type is the linear pair. A linear pair can be defined as the two adjacent angles that add up to 180 degree, or the two angles which when combined together form a line or a straight angle. What is straight angle? An angle with a measure is 180 degree. We already learned in classics, that is types of angles are acute, obtuse, right angle, straight angle, reflex angle. Okay, so I'm not going to discuss again that one. So see here this picture. You can see these two are adjacent angles. Am I right? Angle 1 and angle 2. And their sum should be 180 degree. That means these two angles should be linear pair if angle 1 plus angle 2 is equal to 180 degree. Remember, all the supplementary angles are not linear pairs. Supplementary angles mean that are different angle with the sum is 180 degree. Here, two angles to be linear pair if their sum should be 180 degree as well as they should be adjacent angles. So if sum of two adjacent angles is equal to 180 degree, then that two are called a linear pair. That means their non-common arm. This is the common arm. These are the two non-common arms. So these two non-common arms form a straight line. Then only we can call this is a linear pair angle. So one more thing we can say that linear pair angles are supplementary angles because their sum is 180 degree. So linear pair angles are supplementary angles, but all the supplementary angles are not linear pair. Next one is vertically opposite angles. Vertically opposite angles are the pair of opposite angles formed when two lines intersect or meet. When two lines intersect, the vertically opposite angles are so formed are equal. Here two lines L and M, these two are meeting at a point. Let's call this is O, meeting point. Then the opposite angles are formed. These are the two opposite angles, angle 1 and 2 we can say. So here angle 1 and 2 are vertically opposite angles and they are equal to each other. Similarly, another pair of opposite angles are 3 and 4. Angle 3 and angle 4. So they are also equal to each other. Okay, so we have discussed the relationship between different types of the angles. So these all are related angles. Now let's discuss some question from exercise 5.1. Question number 1, option number 1 is find the complement of each of the following angle. I am taking option number 1. Here the given angle is 20 degrees. So let the complement of 20 degree be x. That is the required angle we have to find. According to the condition, their complement plus the given angle should be 90 degree because they are complementary angles. So the sum of these two angles should be equal to 90 degree. Alright. So we have got a simple equation. We can solve this one. So therefore we can say that x is equal to 90. Transpose this plus 20 from LHS to RHS. We will get a minus 20, which is equal to 70 degree. This is the systematic way we can find. But in this case of complementary, we don't need to go for like this. Also, we can directly find sum is 90 degree. So 90 and subtract the given angle, that is 20. We will get the required angle 70. This is the simple way we can solve. Okay. Similarly, question number 2, that find the supplement of each of the following angles. Option number 1 I am taking here 150 degree. So let the required angle be x. Then according to the question we can say that x plus 105, sum of these two angles, sum of the required angle and the given angle should be 180 degree. Why? Because we have to consider their supplementary angles. So therefore we can say that x is equal to 180 degree. Transpose this 105 from LHS to RHS. So plus 105 will be minus 105, which is equal to 180 degree. Here also we can proceed with the same shortcut I told in the first equation, because this is subtract the given angle from the 180 degree, we will get the required angle because only two angles involved. Okay, so by using simple subtraction we will get the answer, but this is the systematic way. Okay, now let's move to the next question. Here find the angle which is equal to its complement. So here we have to find the angle. First set up the variable. Let the required angle be x, and according to the question this angle is equal to its complement. So sum of these two angles means they are same. Okay, x plus x, both are same angle. The angle is equal to its complement. It should be equal to 90 degree. Am I right? X plus x is equal to 2x, which is equal to 90 degree. That implies 2x is equal to 90. This multiplied 2d, transposing from LHS to RHS, it will be divided by 2. That is equal to 45 degree. It is simple. So set up the linear equation. If you find any difficulty in question, set up the variable and form the simple equation and solve that equation, you will get the value. Next question is, can two angles be supplementary if both of them are acute angles? Yes or no? Let's check it. The measure of acute angle is less than 90 degree. Am I right? Such types of angles are called acute angles. Then sum of these two acute angles will be sum of two acute angles is both are less than 90 degree, then their sum should be less than 180 degree. Am I right? One is less than 90 degree, then sum will be less than, sum of two will be less than that of twice of 90 degree. That means less than 180 degree. That means they cannot be supplementary. No, that is the answer. Okay, because to be supplementary, the sum should be 180 degree. Question number 9, it is a very simple one. In the adjoining figure, refer this adjoining figure, answer this question. Is angle 1 adjacent to angle 2? This is the angle 1, am I right? Is angle 1 adjacent to angle 2? That is the question. Yes or no? Yes, because they have a common arm OC and common vertex O. Therefore, they are adjacent angles. So, yes. Next question is AOC adjacent to AOE? What are the angles given here? AOC. Angle AOC is actually AOC. That is angle 1. So, AO is the arm of AOC as well as AOE. AO is common here. AO is common in angle AOC as well as in angle AOE. So here AO is a common arm. Okay, no problem. But the problem is that the non-common arms OC and OE should be on either side of the common arm. But here it is not valid. See here AO, AO, CE. So AO is a common arm, but the problem is that CO and EO are not on the either side of the common arm AO. That means to say these two are adjacent angles, condition should be like this. AO, CO, C. In this case, we can say this is adjacent angle because the common arm is in between non-common arms. That means the non-common arms on the either side of the common arm. Therefore, they are not adjacent angles. That is the very important thing we have to remember. So this is no. Next, do angles COE and EOD form a linear pair? COE and EOD. See which angle is COE? COE, this angle, angle 2. Okay, and COE and EOD. EOD, this angle. Form a line or not? Linear pair or not? Yes, because the non-common arms COC and OD form a straight line that is called DC. Therefore, they are linear pair. Common arm is OE. Okay, of these two angles. So they are linear pair. Yes. Next question is, are angle BOD and DOA? BOD. BOD means BOD, this angle, angle 4, and DOA. DOA, this angle 5. Are they supplementary or not? Yes, because the non-common arms OB and OA form a straight line. That means they are linear pair angles. Angle BOD and DOA, they are linear pair angles. Linear pair angles means they should be supplementary. Next is angle 1 is vertically opposite to angle 4. Angle 1 is this, okay, is vertically opposite to angle 4 or not? Yes, because angle 1 and 4 are formed by opposite angles formed by the lines CD and AB intersect at the point O. So they are the vertically opposite angles. So S. Next, what is the vertically opposite angle of 5? This is the angle 5. So this angle should be the vertical opposite angle of angle 5. So here 2 plus 3, or we can name as BOC. BOC. So angle BOC. Let's move to the next question. Question number 12. Find the values of x, y, and z in each of the following. First, we can find x. So here x is equal to, what is the relation between x and 55? They are vertically opposite angles, so they are equal. So x will be equal to 55. Reason is that vertically opposite angles. Similarly, after finding x, we can go for finding y. We have, what is the relation between x and y? They are linear pair angles. Am I right? Y and x are linear pair angles because their non-common arms form a straight line. So this x and y, they are linear pair angles. So the sum should be 180 degree. Okay, y plus what is x? Substitute the value of x that we got, that is 55 degree. Okay, replace the value of x by 55, which is equal to 180 degree. What is the reason? We have to mention that is linear pair. Okay, now y plus 55 degrees equal to 180 degree. Therefore, y is equal to 180 degree. When transposing this plus 55 to RHS, it will be minus 55, which is equal to 180 minus 55 is equal to 125. Now what is z? So z is equal to y because they are vertically opposite angles. This y is equal to z, so they are vertically opposite angles. Therefore, z is equal to, what is y we got? 125. So we got the value of x, y, and z. So this is all. These are the questions I have discussed from exercise 5.1. Remaining questions you can try yourself. Now let's move to discuss the different kinds of lines. First pair of lines we are going to discuss, that is intersecting lines. The two lines L and M are intersect if they have a common point. and this common point is called the point of intersection. This is already we know. This is two lines L and M, and if this is the common point, therefore we can call this intersecting lines, and this common point is called point of intersection. Next type of line is transverse. A line that intersects two or more lines at distinct points is called transverse. See here, we have two lines L and M, okay? And another line which is P. If that P intersect L as well as M at two different points, say A and B, then this line P is called transverse. The line P is called transverse because the line P intersect L and M at two different points, say A and B. Therefore, P is called transversal of L and M. This is not only for two lines, for more than two lines also we can call P is a transversal if that is also intersect at the point is minimum two lines, then we will call that as a transverse. Now let's discuss the kinds of angle formed by transverse. There are a total of 8 angles formed. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's discuss the types of angles. First one is interior angles. Interior angles are the angles formed between two lines, okay, inside of this region. So 3, 4, 5, 6. These are the 4 angles in between these two lines. So angle 3, angle 4, angle 5, angle 6. These are the 4 angles. Similarly, exterior angles. Exterior angles are the angles which are formed on the outside, that means in the exterior part of this section, that is angle 1, 2, 7 and 8. Angle 1, angle 2, angle 7 and angle 8. Okay, and next pair of corresponding angles. Here first corresponding pair is angle 1 and angle 5. These two are corresponding angles. Angle 1 and angle 5. Second pair is angle 2 and angle 6. Angle 2 and angle 6. Third pair of corresponding angle is 3 and 7. Angle 3 and angle 7. Similarly, fourth pair is angle 4 and angle 8. Angle 4 and angle 8. Next types of angle is pair of alternate interior angles. They are interior angles, but they are on alternate side of the transversal and also on the different lines. That means angle 3 if you are taking first. Angle 3. So angle 3 and angle 3 is formed on the left side. So we have to take the angle formed on the right side and also formed by the second line, another line, that is there are two interior angles formed on the right side, that is 4 and 6, but 4 is formed by the same line which is formed by the angle 3. So we have to take the angle formed by the line M, that is another line, that is angle 6. The next pair, that means angle 3 and angle 6. Similarly, the next pair will be angle 4 and angle 5. Satisfying this condition, angle 4 and angle 5. Next type of angle is pair of alternate exterior angles. Same way as we have taken interior angles. Angle 1 and another angle is here, so we have to take the alternate one. Angle 1 and angle 8. Similarly, angle 2 and angle 7. They are alternate exterior angles. Angle 2 and angle 7. And the last category of angle is pair of interior angles on the same side of the transverse. They are a pair of interior angles, but they are on the same side of transverse. That means angle 3 and angle 5. They are interior on the same side of the transverse. So angle 3 and angle 5. Similarly, angle 4 and angle 6. Angle 4 and angle 6. So these are the categories of angles when two lines intersecting by a transversal line. Now let's discuss if these two lines are parallel, then what we can say about the properties of these types of angles. See here also we have 8 angles, but the condition is here the line L and M are parallel lines. That means they never intersect and always keep the same distance between them. So here as these two lines intersecting by a transversal line P and form 8 angles. Okay, let's see the properties. First property is that if two parallel lines are cut by a transversal, then each pair of corresponding angles are equal in measure. Okay, only one in measure. That means their measure is equal. So what are the corresponding angles we have here? So what are the corresponding angles? Angle 1 and angle 5. They are first pair of corresponding angles. So they are equal. So angle 1 is equal to angle 5. Similarly, second pair is angle 3 and 7. Angle 3 is equal to angle 7. And third pair is angle 2 and 6. So angle 2 is equal to angle 6. Also angle 4 and 8, that is fourth pair, so they are equal. Angle 4 is equal to angle 8. Next one is that each pair of alternate interior angles are also equal. What are the alternate interior angles here? Angle 3 and angle 5. Angle 3 and angle 6. That is the first pair of alternate interior angles. So they are equal. Angle 3 is equal to angle 6. Similarly, angle 4 is equal to angle 5 because they are the second pair of alternate interior angles. Angle 4 is equal to angle 5. And the same property we can also state in case of alternate exterior angles, but we are not going to discuss that one. Okay? Next one is each pair of interior angles on the same side of transversal are supplementary. That means another name of interior angles on the same side of transversal is co-interior angles. Co-interior angles. They are supplementary. That is the third property and is very, very important. So angles 3 and 5. These two angles are the interior angles on the same side. They are supplementary. Therefore, we can say that angle 3 plus angle 5 is equal to 180 degree. Similarly, angle 4 and 6, they are also supplementary. Angle 4 plus angle 6 is equal to 180 degree. Now let's discuss some questions from exercise 5.2 to apply this concept. State the property that is used in each of the following statement. If AB parallel to B, then angle 1 is equal to angle 5. A is parallel to B, then angle 1 is equal to angle 5. Which property we are using here to state they are equal? They are the corresponding angles. So corresponding angle property. Corresponding angle property. Second one is if 4 is equal to 6, then A parallel to B. 4 is equal to 6. 4 and 6. Here 4 and 6 are alternate interior angles, then only this. If the alternate interior angles are equal, then these two lines are parallel. So we are using here alternate interior angle property. Alternate interior angle property. Similarly, in third question, that if angle 4 plus 5 is equal to 180 degree, angle 4 plus 5, they are the interior angles on the same side of 180 transverse. So they are supplementary. Some should be 180 degree, then these two lines should be parallel if that condition is satisfied. So co-interior angles property. co-interior angles property or interior angles on the same side of supplementary that property. Okay. Now let's move to the next question. Find the value of x in each of the following figures if L parallel to M. L is parallel to M. We have to find first one I'm taking here. Value of x. What will be x? What is this angle? This will be 110 degree. Right? Because they are the vertically opposite angle. Now we can easily find the x. Because x and 110 degree are the supplementary angles because these angles are the interior angles on the same side of the transversal. So they are supplementary angles. Okay, co-interior angles. Interior angles. So here x plus 100. So we have a linear equation. We can easily find. Therefore, x is equal to 180 degree minus 110 degree. Transposing this plus 110 to RHS, we will get minus 110. So 180 degree minus 110 degree is equal to 70 degree. So the value of x is equal to 70. Similarly, you can try other options. Option 1 I am going to do here. Option 2 you can try yourself. Okay. So here the arms of two angles are parallel. These two arms are parallel. And if ABC is equal to 70 degree, find DGC. DGC we have to find. DGC we have to find. So here we have AB parallel to DE because the arms are parallel, and also BC as a transversal and transversal BC. Therefore, we can say angle DGC is equal to angle ABC. Why? Because they are the corresponding angles formed by this transversal. Corresponding angles. Corresponding angles are equal. These two become the corresponding angles when these two are parallel lines and this is a transversal. So we can say that angle DGC is equal to, what is ABC? ABC is 70 degrees. So that also will be equal to 70 degrees. Okay, very simple. Option number 2 you can try this. And question number 6, option number 1. In the figure given below, decide whether L is parallel to M or not. Here just these two angles are co-interior angles. So just to find the sum. So we have 44 plus 126, which is equal to 170 degree, which is less than 180 degree. So they are not supplementary. They are not supplementary. Therefore, L is not parallel to, because as they are co-interior angles, interior angles on the same side of the transversal, they should be supplementary if L is parallel to M. But here they are not supplementary, so L is not parallel to M. So this is all about this chapter. So it's time to wind up this video. So I hope you got a clear idea about these lines and angles. So in the next video, I will discuss another chapter. So that's all for today. Thanks for watching.